free fatty acid. Fatty acid. And also a head group. This structure, which I have illustrated for you, is a structure for phospholipids. This is a phospholipid structure. When phospholipids miss one of their fatty acids, we have lysophospholipid. If a fat if we have a phospholipid, a bilayer structure will be created when dissolved in water. On the other hand, when we have lysophospholipid, a micelle structure will be created when dissolved in water. No problem? Do you understand? Very good.
Dr. This is all what we need to understand about the lipids and the water mixation, is all? There's another thing?
In fact, known lipids do not dissolve in water. In fact, they escape from water and accumulate with each other, so that they move out water between them and accumulate with each other. Let me see the picture, a figure that can easily tell you about this. As you can see here, if we have
Şaka. Diğer.
As you can see here, when lipid dissolve in water, they escape. See here? They escape from water molecules and accumulate with each other. In fact, lipids are hydrophobe. Hydrophobe. It means
Scared from the water?
yes, very good. They fear from water. They don't like water. So they accumulate with each other and create shapes like micelles or bilayer lipids. And as I said, if we have a lipid with a, let's magnify the shape. If we have a lipid with such shape, with a rectangle shape, or conical lipid, like lysophospholipid, like sodium dodecyl sulfate, so a micelle structure will be created. On the other hand, if we have a cylindrical lipid or rectangle shaped lipid, like phospholipids, bilayer structure will be created. And as you can see here, there is no water molecule between lipid molecules. They move out water between. Ahmed asked me that about these shapes. How can we describe this shape in final example? Another question that I. Yes, very. The important feature about this lecture, about this subject, is that you should know that water don't like lipids and vice versa. This is the important one. So you should just know that when lipids dissolve in water, we can say that lipids are not really dissolved. In fact, they accumulate with each other. As you can see here, they accumulate. There is no bond between them. There is no bond between lipids. They are just accumulated due to water. There is no bond between water, lipid molecules. They are just located near each other. So you should describe that lipids, when lipids dissolve in water, they fear from water. In fact, they are hydrophobe, and they accumulate to each other. There is no bond between lipid molecules. So between two lipid molecules, we can't see any bond, any joint, any other structure.
يعني example lipids are afraid of water, but they accumulate to each other.
But we can say and accumulate to each other.
And accumulate
To each other.
Doctor, bilayer and mesos told them. Same thing?
No, bilayer has some differences from mesos. As I told you in our last session, in meso structure, there is no area, no free area, no bulk area. However, in two-layer structure, we have a free space inside the structure, yes, which is full with water.
Like this here.
Like so.
I have a question. You say there is no water between the lips and fats. How the lips and the fats that if there is no water, how it's dissolved in water?
They are not dissolved in water. As I told you, they are not dissolved in water. They just accumulate in water. Let me tell you about another example. كاكي gelmekiyim ben ve avuç ve şile yani avuç için. We have a type of food in Kurdish, just a Kurdish food. We name it avuç. I don't know. I think you name it Bozi or Shila. I just want to. Yeah. No. Another type of food. As you can, if you can see this type of food, you can easily see that lipid structure located on the surface of Water.
Water, yeah.
So, lipids do not dissolve in water. If this structure dissolve in water, you are not able lipids on the surface of water. So lipids do not dissolve in water.
Understood.
They just accumulate near each other because they fear from water. And they will try to escape water. They do anything to escape from water.
Just the tail. Because
Yes,
the-
of course, the tail of them are hydrophobic. The head group is hydrophilic, but the power of tail is much higher than
the head.
head.
Yes.
I hope you completely understand my explanation. Very good.
لا شكل توي سؤال يعني سلم إلى قوي يبدأ عنده نفس الوالدين على سليمية نسد الإبز ممكن الإبز قوي يقول ما يسافر لبوي ما يعمل accumulates with الإبز كده شيء تجي الوالدين كمان من بعض الشيء
Okay, I write the main point.
the main points of the slides.
This is slide. Right.
Alright.
So please write this point for the previous this slide. And lipids. One. Lipids or fats. Do not dissolve in water. Two. Lipids or fat are hydrophobic. Lipids or fat accumulate near each other to escape from water and have the minimum interact. H2O small. Four. The head group of lipid or head groups are hydrophilic 5, 28. Structure in water. So you see the and search.
دكتور طيب ما نفرق جوجونا بيجي ليكم
The points are: first, lipids or fat don't dissolve in water. 2. Lipids or fat are hydrophobic. 3. Lipids or fats accumulate near each other to escape from water and have the minimum interaction with H2O molecules. 4. The head group, of course, we have a variety types of head groups. The head groups of lipids or fat are hydrophile, which means they like water and they can have a joint, they can have a bond with water. In contrast to tail group. 5. Lipids and fats create two structures in water. The first one is micelle and the next is bilateral structure. So you learn that in our body water can dissolve various types of molecules like polar and ionic molecules. However, molecules like fats, molecules like non-polar structure, which have non-polar structure, do not dissolve in water. They are hydrophones. In contrast to hydrophile molecules. I have a question, but I don't answer this question now. We will learn about this question in our next sessions. The question is, as you know, in our blood, we have fats like cholesterol, like triglyceride, like another molecules of fats. So the question is, how fats dissolve in our blood? We know that fats do not dissolve in water, and also we know that our body constructed from water. Our body is constructed from water. We learned that in our last session that in male about 70% of total volume of body is water. For women is about 65. So, how lipids are dissolved, are transferred in our body? We need lipids, we need cholesterol, we need triglycerides and other lipids. Our cells need lipids. How this lipid transfer in watery blood? How lipids are transferred in watery blood? We will answer this question in our next session. Yes?
We to use special enzyme for the breaking of fats? in the
No,
blood?
none of enzymes are used in this manner.
Because the structure of blood don't contain only water. We have exocrine and endocrine excreted that help to
No,
slow the
no.
So of high cholesterol in the blood.
No. If you wait, you can easily get the answer. But if you do not still wait, I will give you the answer. We need a structure to cover the lipids in our blood. Cover the lipids in our blood. I mean, we have a structure in our blood that can dissolve in water. We name such structures as lipoproteins. So we have some proteins that covers lipids and transfer it in our blood. Can you name some of these lipoproteins in our blood? I am sure that you are aware about them. Can you name them? No?
No.
No.
I don't understand. I still
So don't sleep.
and translate to Arabic.
So don't sleep, don't know. Well, the first one is LDL.
The second one HDL.
HDL.
It's in the blood.
VLDL, yes. These type of lipoproteins cover lipids and transfer them in our blood. For example, LDL transfers and transferred from cholesterol and transfer cholesterol to our tissues, to our شانه بالعربية قشر transfer cholesterol to our tissue قشر
مو قشر نسيج.
to our tissue. On the other hand, HDL, of course we have also IDL. On the other hand, we have HDL, which transfer cholesterol from our tissues to liver.
Kevin.
To liver or heart. So, we name LDL as bad cholesterol and HDL as good cholesterol. Do you know why?
Because high density.
LDL is a low density of lipoprotein. HDL is high density of lipoprotein.
Yes, this is the abbreviation for this type of lipoprotein. But why we can name it as Ahmed? Bad lipid and this type as good lipid.
The LDL contain the lipids in the tissue. Don't use it.
No, I said to you, both of them are constructed from cholesterol. The main lipid in this type of lipoproteins is cholesterol. But why?
Doctor?
We named it bad cholesterol or bad lipoprotein, and this type is
Doctor, the first one is separate the lipids to the tissues, and the second one take the tissue, let's say lipids from the tissue to the to the liver to be dissolved.
You?
On the LDL, the fat is communicated by the vessel, and the HDL is removed.
Move it. Okay. You?
Make up most of the hemoglobin normal.
Let me explain the reason. When a lipid transfer to tissue, just let me say that, when cholesterol transfer to tissue, which tissues? Like our heart, our kidney, our brain, our venous, our other دماغ
الشريان
دماغ acid. When cholesterol transferred to these type of tissues, if the lipid are more higher than our needs, so lipids do not consume and accumulate in our tissues. It is very harmful and damage our tissues. The very important disease that results from accumulation of cholesterol in our tissues is atherosclerosis, which is the collapse of our artery or veins, and lead to myocardial infarction or heart attack. So, if we do not consume, if our cells, our body do not consume the lipids, they accumulate and can lead to several diseases. However, HDL transfer lipids to our liver, which then help us clean. Yes, very good. Yes. Liver will clear our body from such lipids
Harmful cholesterol.
in the way of structure of bile salts. Our liver change cholesterol to bile salt and and remove them from our body through stool, through feces, stool. Yeah,
Okay. Feces?
Metaphor. Through stool, bile salts. Bile salt enter to our GI system, gastrointestinal system, and from our body through stool. No problem, you understand? Okay, very good. As you can see here, we have two various type of bones. Two various type of bones in our body. The first one is covalent. Let me see. Covalent bone or covalent interaction, which are covalent bonds or covalent interactions are strong joint, strong connection between two molecules, like a bond between two C or 2 carbon. This type of connection is a covalent bond. The other type of connection are non-covalent interaction or bond, which are divided to 4 different types. The first one is hydrogen bond. The next is ionic interaction. The next is hydrophobic interaction. And the last one is van der Waals interaction. I explained these 3 interactions, like hydrogen bond, ionic interaction, and hydrophobic interaction. The last one creates when 2 atoms, not molecules, 2 atoms. Do you know what is the difference between atom and Very good. When 2 atoms close to each other, locate to near each other, when they are far from each other, we have no van der Waals interaction. But we close to each other in a fraction of second, in a fraction of moment, an interaction named van der Waals interaction create. No problem, you understand? So, van der Waals interactions happen between 2 atoms, not 2 molecules. 2 atoms. Very good. I explained that in a fraction of second, in hot H2O molecules change to H3O plus
OH
and OH negative in a fraction of second. So we can expect that in a water solution, in a solution that consists just from water, we have both H and OH ions. So, what is the construction? Construction. Construction غلظت رجال. If عدد or construction, عدد or construction, what is the construction of H and OH? What is the construction عدد? What is the عدد? عدد. What is the construction of H and OH in this solution? As you can see here, the construction of H and OH is equal to each other and is 1 multiple 10 power minus 7 mole. 10 plus minus 7 mole. 10 plus minus 7. So, you can see that this amount is too low.
below the zero.
If we want to talk about such low amounts, we use another explanation. We use another symbol, which means pH, and is equal to minus logarithm of H. minus log and it is equal to 7. So, as you know, the pH of a pure water, pure water, or خالص, ماء الخالص, is equal to 7. Again, the pOH of such solution is also 7. So the pH is equal to pOH in a pure water solution. In a pure water solution. So, if we have a solution with pH lower than 7, we name such solution as acidic solution. Or if the amount of H is higher than OH in a solution, this solution is acid. Or tersh. On the other hand, if the OH construction
is higher
or amount is higher than H, we name such solution alkaline or basically So, some examples. 1 mole of NaOH or soda is about 14. The pH of such solution is 14. Household bleach. Household bleach.
Bleaching
Some type of cleaner in our house that your mom used them to clean toilet or other. Household ammonia again. Solution of baking soda. On the other side, 1 mole of HCl. Gastric juice. Our gastric juice has a pH equal to 1.5, about 1.5. Very acidic solution
to dissolve the food
in our gastric. Cola or vinegar? Cola. You know cola. So when you drink cola, a high amount of acidic solution enters in your body, and your body needs to fight with such solution. I will tell you why your body needs to fight. Again, black coffee, beer, tomato juice, red wine, all of them has an acidic property. They are most acidic. Your body needs to fight them to remain the pH of your body in this amount, 7.4. Right? This amount pH of our body should be remain 7.4. Very important. You know that for most animals, for most molecules in our body, like glucose or sugars, when you go to a laboratory, clinical laboratory, and you test your blood glucose, a range is written for your glucose, and it is about 65 to 100 milligram per deciliter. This range is the normal range for your glucose in body. But with regard to pH, we don't say reference range. We don't use reference range. We say normal point. There is no range. And this is very important. You should know that for pH, we don't use range. We just use a point, 7.4. And your body needs to remain this very exact point for your pH. You can see here, egg white has an alkaline property, but most of our foods, like milk, has acidic properties. So when you supply this type of foods, your body acidity will decrease. And your body need to increase this level to the normal range. Well, هيك هو فقط مصور بالذات فقط زادك جميلة
يعني يقولون لك
ويجيني بس يعني بس
باش
Ahmed asked that if we don't use any diet with an acidic or basic properties, and we use only diets with or foods with neutral properties, are still our body need to fight with this type of food or diet, or is still our pH decrease or increase? Yes. Why? Because in our body there are some type of process that produce acid or base. For example, when you run, when you do some physical activity, when you play football or other physical activity, your body produces acids named lactic acid. So your body still need to remove this acid. Okay.
باش كويسه هنا شفت البرودكت يقولون عليه outline بس يسمونه حاجه باش باش يسبوا بس هي outline او فقط شيء وتري
we have such waters. We named it in Iran soda. That some type of water that includes some gas in there. This type of gas is CO2 that produced base. So this type of water is alkaline water.
هي دكتوري مشابه مسابقة بس إذا غاز كيف
Gas can
هي اسمه خواردون هي بس إذا غاز كيف
yes, sure. Such water are alkaline water because of the CO2 inside there. And when you use this type of water or cola in higher amount of your body, maybe your body cannot remove this type of alkaline or acid and leads to some disorders. For example, your acidity decrease or increase, and this is very harmful for your body. Do you know why? Why decrease or increase of your pH is harmful? Or let me ask you a question. You will answer this question. Both pH, both changes in pH and temperature will extremely hurt your body and are very harmful for your body, both pH and temperature, high temperature. Why? We will ask you this question. No. We know that, we learned that can I clean the board? Can I clean the board? Look. Yes.
The higher will makes a lot of problems in the proximity of our cells.
هو يقول لك ليش؟ هو يقول لك ليش؟
هو بسبب التناقضية اللي بالخلايا مالتنا. إذا ارتفع التركيز أو إذا خفض التركيز فهي متعودة تكون محلول تعادل ليش ما تسرع؟
يعني السيستم إلى شو بيتفق؟
Well, first, just keep in your mind, our normal pH is not a neutral pH. Our normal pH is 7.4. So it is some likely to be alkaline. The first. Any change to this amount, for example, if we have a pH like 7.3 or 7.5, leads to disorder. No problem, what is the amount? Any change leads to the disorder. Why? I will tell you in our class. But any change leads to disorder. In fact, changes in pH is the only analyte in our body, pH, the only test in our body that create very harmful disorder for our patients. So we need to manage, to monitor the pH of our patients in an exact manner. And if the pH change to higher or lower amount, we need to remain it to normal. With using some drugs, some oxygen, and so on. I will tell you what is the importance of pH, and also how can we remain or compensate these changes in pH amount in our body. Well, As we learned, H2O molecules could be existed in two types, OH and H. So, and also we learned that if a salt dissolving water, H molecule cover
the Cl.
negative
Negative.
charge ions
Cl.
like Cl,
Like Cl.
and OH
Like
cover
sodium.
positive.
Like sodium.
Very good, like so. What about the other type of ion form? Like acids. What happens if an acid dissolving our body, our cells, our blood? First, we have two types of acids. The first one is strong acids
Weak acid.
like HCl. The second one is weak acid like let me name another example, H2CO3 or bicarbonic acid. Bicarbonic acid, which is a very weak acid in our body, and also a very important, be quiet please, guys, be quiet, and also a very important acid in our body. What? I will talk. Well, when HCl dissolves in water, HCl completely separate, dissociate to H plus Cl. However, when bicarbonic acid dissolves in water,
H plus HCO2.
it produces H plus HCO minus. And this equation is reversible,
We can
unlike HCl, because H2CO3 do not completely dissociate, do not completely separate. We have still some amount of the acid. So, in two sides, we have acid and we have a base. Acid is the molecule that can give a H ion. On the other hand, base is a molecule that can give a H ion. Again, acid can miss the H ion, base give an H. So, weak acid do not dissociate completely. On the other hand, strong acid completely dissociate. Just if we illustrate the dissociation differentiation constant or equation. The equation is like this. So, please tell me that what is the calculation for this equation?
K.
Sorry?
K.
Ka. Because we don't have any HCl in this solution. So the amount of HCl is 0 or zero. And if we want to calculate this equation, the equation is infinite. Infinite. What about the other equation? For this type of equation, because the amount of HNHCO3 is very low, and the amount of the left side is too high, the final result is very small and too low. So again, we should use P for this equation. K stands for constant. Sabit. Stand for constant, which means any equation has a unique pK. A stands for acid. Any equation has a unique pK, which do not change and do not relate to the equation. It is a sabit amount. Do not change. So, we have pK for such type of equation. Well, as I said, changes in pH and temperature definitely hurt our body. But why? What is the importance and function of H in our body? H has too many functions. For example, transport of oxygen in our blood. We know that RBCs and hemoglobin transfer our oxygen. What is the role of H in this process? What? In our body, near your lung, near your lung, the amount of oxygen is high and CO2 is low. CO2 is low. to the equation, you should keep in your brain, keep in your memory this equation. This is very important from now to the end of your career as a GP, as a general practitioner. This molecule can easily transform to CO2 and H2. Can easily change to CO2 and H2.
So it is H2O, CO3.
لا بدو اتش
Well, sorry. Can easily change to this molecule without any enzyme reaction. So we can say that one side of this is our acid and this is our base in our equation. And because H2CO3 can easily change to CO2 and H2O, we can name CO2 as our acid in this equation. So two sides of our equation are CO2 and HCO3. Again, our acid is CO2 and our base is HCO3. So, if the amount of CO2, increase, CO2 can produce H2CO3 or our acid. So, CO2 is equal to acid. So, if the CO2 amount increase, the amount of pH decrease or increase? Very good. Decrease. So we have a indirect correlation between CO2 and acidity or pH. Very good. As I said, okay, again I explain. As I said, H2CO3 can easily dissociate and change to CO2 and H2O. Vice versa, H2O and CO2 can easily produce our acid. So, the amount of CO2 and H2CO3 is equal to each other. We don't use any enzyme to produce this type of molecule or this one. They can easily changeable to each other. So, if the amount of CO2 increase, the amount of pH decrease, or as our acid is increased. Well, as I said, the amount of CO2 near our lung is low. In contrast, the amount of oxygen is high. On the other hand, the amount of in our tissue, the amount of CO2 is high. On the other hand, the oxygen is low. Very good. So, when the amount of CO2 is high, so the pH is low. The pH is higher. Something like higher. Not much, but it is higher. Not much, but it is low. So, when our RBCs, our hemoglobin, close to our tissues, with a lower pH, they missed their oxygen because of the lower pH. Of course, in fact, hemoglobins give a H plus ion and one oxygen removed from our hemoglobins. Hemoglobins give a H plus ion and miss a O2 molecule. So H can help our RBCs to transfer their oxygen to our tissues. Enzymatic reaction, this is the point that I emphasize about it. Why H and temperature, high temperature, is important to our body? Well, the workers of our body are proteins and especially enzymes. Enzymes are some types of proteins. Are the kind of proteins. So, in the first slide of our last session, I told you that pH impacts on both structure and function of proteins and nucleic acids. Again, pH impacts on both pH impacts on both structure and function of proteins and nucleic acids. When pH change, the structure of protein changed. Again, when pH changed, the structure of proteins will be changed because of the changes in the pH. So pH can change protein structure. When protein structure change, the function of our proteins will be changed. What is the function of our proteins? Any reaction, any function in our body needs proteins, needs enzymes. So if we don't have proteins, if we don't have enzymes, no action will happen in our body. So we will die. That is why the changes in pH is very important for our patients. You need to monitor your patient for its pH. Which patients? Patients who are hospitalized in ICU departments. They have no action. They are in coma. They are in a comatose status. So you don't know what happened in their body. So you need to monitor her or his pH to find out what happened in his or her body. Again, the impact of high temperature is similar. High temperature
درجة عالية، درجة حرارة عالية.
درجة حرارة عالية.
High temperature is yaw in Kurdish or high has a similar impact in our proteins. High temperature degrades our proteins. So the structure distracted and their function will be changed. That is why we monitor the temperature of our patients, especially for children. If children have high temperature, higher than 40 degrees of centigrade, this high temperature can lead to some very important disorders and lead to die of children. Therefore, we need to monitor both high temperature and changes in pH. So enzymatic reaction needs pH. It creates energy in our body. What is the relation between H and energy? You can find out about it in your next term that H plus ions can produce ATPs in our mitochondria. You should just know that H ions can produce ATPs in our mitochondria. How? We'll learn about it in our metabolism and its regulation. Measurement of pH of blood and urine are commonly used in medical diagnosis, as I told. Well, enough for this session. And we will continue to this part of lecture. No. Today in 13 to 15 because I am not here in Senede in Thursday. So we have a small change in our schedule for this week. Just for this week. Our practical lecture
Next week.
no is in changed to Thursday. Wait a minute. Changed to Thursday, and today we have theoretical lecture. Tuesday. So, I'll give you